Since you started ignoring me when I come to you to ask you to sit, I'll just start like this and ask you to make yourself comfortable because we are starting with Fatih's lecture, which is the ultimate battle of large language models. So Fatih, and please,
Hi, my name is Fatih, and in this session, I will discuss and compare the current large language models to identify the optimal one that aligns with our specific requirements. When we created the internet, we started loading lots of data to it, and it created another problem, the search problem. I mean, we need to create the search engines. But it didn't solve all our problems. We cannot do the search in a semantic way, right? Imagine that you are planning a trip from Istanbul to Sarajevo. You need to search for transportation, search for places to stay, and find the best places to visit or where to eat meal. So in order to solve this problem, almost 15 years ago, the academicians established an organization called Linked Open Data. I'm not sure if anybody here linked data or linked open data. I heard it because it was one of my term projects in the university when I was doing my master's. So the idea was to, they have 5 principles, right? One of them was to make the data public. It has to be available to everybody. It must be text-based so that the other ones can process it. And it should be in CSV format. And another thing, it should support a specific query language called SparkQuery, and it should be linked to another data in its data store. Basically, it means structuring the whole web. It's crazy, right? I mean, when I first saw this, I said, this is not going to work because we humans are lazy. We will not put spatial HTML tags in HTML bodies to structure the data to make it useful for someone. So we needed a better way. So as we discussed yesterday, NLP is not started with AI. It was there before that, but it had lots of challenges. Like it doesn't understand the context. I mean, Adnan explained it in a very good way. It's very crucial to pursue a conversation. So, but the earlier NLP models didn't understand the concept. They weren't generic. We were finding a solution to a problem, but you couldn't apply it to another one. They didn't have sense of humor, like the lettuce example. They need lots of manual intervention, and they have some kind of dictionary, and they couldn't go out of it. They cannot find or guess the meaning of a new word. So we all are using ChatGPT. I know you are, and I bet most of you have used it more than me and in a better way. But I had some experiences with it, and please allow me to share some of mine with you. I have 3 daughters at the age 15, 8, and 12. After the eruption of ChatGPT, I thought that as a responsible father, I need to explain, at least try to explain it to my children. maybe we can find a good way of use case. So I try to explain them AI, generative AI, and ChatGPT. And I also showed them some tricks with ChatGPT. Queried something, but they weren't as much amazed as I expected. Maybe it's because it's text-based. Maybe I couldn't tell it in a good way. But the following day, I saw my elder daughter sitting in front of the computer and taking notes to her notebook. So I asked, "What are you doing?" "Homework," she replied. And I saw ChatGPT on the screen, and I asked her if she was doing her homework with ChatGPT. She said yes. At that time, my concern shifted from ethical aspect to fear of her getting caught, because I know ChatGPT was generating very advanced texts. She was only freshman at high school, so she will probably get caught. So I started explaining this to her. She stopped me and said, "Don't worry, Dad. I told it to prepare it in high school." Probably it, but how could she know that? I mean, we are trying to educate ourselves to be better prompters. We are taking some lessons to how to prompt better. But I mean, Gen Z, I think they are interacting with Gen AI better than us. After a couple of days, I remembered that I forgot my account logged on. And I think this is my 8-year-old. It says how to change my eye color to blue. She was asking ChatGPT these kind of questions, like how to change our hair into curly, how to make our hair curly, or why do cats shed their fur? So I think it's kind of working. And for me, I'm not as coding as much as I used to, but I still try sometimes to exercise to catch the latest trends. So when ChatGPT first published, I tried some exercise on it. This is a common, famous coding problem. It's very easy. Finding the maximum number of consecutive ones in the array. Here it's 3 because it's 3. I mean, the algorithm is not very important here. It's generated in seconds, obviously, but it's a simple one. The important thing here is, I'm not sure if you can see, but in line 22nd and 24th, it can be one line, right? It's using that variable and returning that variable. It's correct, but it can be one line. And it's always a design decision or discussion. So I asked it, why did you do like this? It can be one line. And it replied to me that obviously for readability. I mean, it's not just generating code, it also understands it and it knows how to write better code and the difference between the good and better code. So it can just grab this result from Stack Overflow, but it can give some meaning to it. I mean, it was like coding with a master, pair programming with a very patient master developer, because you can ask lots of questions to it. I also use it for like determining the time complexity of the methods which I suck at, or like refactoring code. I'm not sure if all of you know Star Trek, the TV series, which was first aired in '66. There are some similarities I can pick. I could pick. Like there was a. I mean, I hope you all know Star Trek. There was a ship traveling in the space and encountering a new species in each episode. So there was this main computer, and everybody can interact it with via voice. And the main computer is like an assistant. It can control the ship. It can run some repetitive tasks. It can search any information. You can ask Google these questions. It can analyze psychology, mechanical engineering, or something like that. And it can locate a crew member. I mean, you can ask, where is Jihad? It can say, he's somewhere. And it can give you benchmark information about the ship. But it never makes a critical decision. It's up to the crew to make the last call. And I think in one of the episodes, the ship AI gained some consciousness, and they had to declare it as a new life form because they had to. And in that series, there is also a concept of universal translator. This is a mechanism that can, I mean, in every episode you meet a new species that speaks very different language. And there was this concept of universal translator. It knows all the languages in the universe, and it can adjust or learn a new language in seconds. So, I mean, that I don't know you, but these kind of things reminded me. I think there's a connection between generative AI with these kind of things. Okay, but what is a large language model? Before that, we need to define Gen AI or generative AI. It's like it's a type of AI that creates new content based on what it has learned from existing content. I mean, you give it content, it learns it, and generates a new content from it. And this process is called training. We get foundation models and adapt it, and we have other sub-Gen AI phenomena like large language models. So I asked Bart, Google's ChatGPT, like, what is a large language model? I think Bart is not available in Sarajevo, in Bosnia yet, but I think they will release it in time.
It is from a couple of days ago.
I tried yesterday, it wasn't. We can try. It wasn't in Turkey, and I think 2 weeks ago they released it. It defines itself like, I'm a large language model. I mean, a large language model is a type of AI algorithm that uses deep learning techniques. I mean, we talked about this yesterday. But it says it can understand. Understand is a bold verb, I think, and it's something humanoid. I mean, we don't use it for machines, but it feels like that. I mean, remember my coding example. I felt like it is understanding something. So it can summarize text, generate text, etc. And it has some examples here, but you see the problem here, right? It's repeating itself. So it's not perfect yet. It's good, but it's not perfect. So I mentioned earlier NLP systems before, and they had some flaws. With large language models, they have been solved. I mean, they can understand the context. They are generic now. We can apply the single model to different problems. They have sense of humor now. They don't need, or they need little intervention. They can guess the meaning of a verb in the context. So When we look at the large language model world, there are some companies here. I mean, there is OpenAI, the biggest one. We know that. We have Google AI, we have Meta AI. It's Facebook's company. I mean, Facebook, formerly known as Facebook. Microsoft is also working on some large language models. We have Hugging Face. Actually, Hugging Face is not a direct producer of original models, but it's a great platform that you want to, if you want to play with large language models. And it also provides a transformer library. And we have other companies like AI21, Anthropic. There are lots of, these are the ones that I picked that I believe the bigger ones. So in time, large language models evolved like this. Imer yesterday mentioned the paper, the attention is all you need paper. After that, the transformer-based LLMs has been adopted. BERT or BERT was the first one, developed by Google. After that, more had come. But here, I mean, the ones that are on the same branch has some relations, and we are seeing three different colors. Pink ones are decoder-only models, green ones are encoder-decoder, and we have decoder-only models on the blue three. And hollow ones are closed source, and shaded ones are open source. So we see that there is a shift to decoder-only models. There are lots of them. And also there is a shift to closed source models because the idea was generating money and to monetize it. Okay, but why? Why did we shift? Why did they shift to decoder-only models? Because compared to encoder-decoder models, decoder-only models were easier to train. They can accomplish much wider tasks compared to encoder-decoder models, and they are effective. So here we can see them in architecture-based. They all, I mean, in the LLM area, encoder-only models are being called like BERT-like models because it's the first one, and decoder-only models are called GPT-like models. So these are the areas that they are specialized on. We can say that encoder-only models focuses on the inputs. I mean, we give them text, they generate text. If we are using an encoder model, it's performing its best by focusing the input, like text classification. I mean, we give them a text and want to classify. Whereas decoder-only models are focusing on the output, like generation of text. And we can see that, by the way, they can accomplish or perform any task, any text-to-text task. These are the ones they are very good at. So decoder, we can see that decoder-only and encoder-decoder models can translate, but in decoder-only models, they can translate in an efficient way. Whereas encoder-decoder models are good at accurate translation. That's the difference, main difference. So this is the graph of top 15 large language models. You can see that they don't live much, right? They have like 2 years of survival. They short-lived. But why? Because the research process is still going on. We are inventing or innovating a new model every day. And it's very costly to maintain a model. It requires very high resources. It's spatial hardware, actually, like TPSs, tensor processing units. And it's very costly. So only big companies can maintain them. So we will be seeing this kind of new LLMs, and the current LLMs will be dying in this period. Okay, let's try to compare the large language models. I try to prepare this table. Green means bad, light green means good, and yellowish means okay. I mean, they can perform. I have picked randomly, the biggest ones if I can find. And they can perform all of these tasks, but the darker ones, darker shaded areas, they can perform better. We can see that like decoder-only models, which are focusing to the output, are bad at text classification and information, whereas they can do conversations, summarizations, translations, or content generation. And here we can see the parameter size, where parameter size really matters. It's an important aspect. It defines the accuracy and complexity of the model. There is a positive correlation. But it also brings another burden. If the model is very big, it's very hard to maintain. It requires lots of resources. So there is Paul here. Actually, it's running behind BART. And I'm sure you know that, but I think I need to mention that ChatGPT is not a language model, right? It's just a product, a good product based on GPT-3 and GPT-4. Like BART. Actually, Palm is running behind BART. Another aspect is the training data. I mean, there is the dog analogy here. I mean, if you pick a puppy and train it to be a guard dog, it becomes a guard dog. If you train it to be a rescue dog, it becomes a rescue dog. It can perform other dog stuff, but it can perform the task which it's trained for. It's like this in the training models, in the language models, like AlphaCode. It's just trained with code, so it can perform generating code compared to other language models better. I know you are thinking that ChatGPT is generating codes, but it's not trained by code, but it has scrolling data, web pages, and it contains Stack Overflow. I mentioned Hugging Face. Let's try to look at it. I said it's a great environment if you want to dig in. It has models here. It has this nice grouping, like our language models are here. If you want to make text classification, let's choose translation. It shows us the most downloaded popular models that can translate. You can go into it and it shows a short description. And you can try here some of its properties. Hugging Face also provides a leaderboard. I cannot. Okay, let's try this. There are some metrics that are these models are tested on, like ARC, LSD. I mean, the definitions are in the Hugging Face webpage, but they are like SAT exam for GRE scores. They are testing these models like we test humans. So based on the scores, they are preparing this leaderboard, and you can choose the appropriate one if you wish. But it's changing very frequently. Another website I'd like to mention is it's a consortium built by students of Berkeley. This is, you can battle the models, like prepare a presentation. I think, yeah. About ultimate battle of language models. There are some typos, but it's kind of slow. But you cannot see the model's name. You don't know which model is this. Okay, they started battling. I mean, this model is suggesting an introduction, conclusion, slides, even the content of the slides. The other one is like, I don't know, just texts. So okay, then you can vote. Which one is better? The one on the left or right? Or is this a tie, or they are both bad? Let's say tie. Then it revealed the names of the models. It says the left one was Koala with 13 billion parameters, and this is MPT. And they are building their leaderboard here based on these votings. And you can see that GPT-4 is the best one compared to these ratings. And they also have these kind of scores. And they are like, as I said, like GRE scores. They are actually testing. Okay, but how will we choose the appropriate one? There are some criteria. Okay, who is going to use it? I mean, if you are a regular web user, probably you're going to use ChatGPT or Bar. If you're a developer, I mean, if you have a programming background, maybe you prefer an API-based model, a model that provides an API. Or you can use Hugging Face platform to get yourself used to it, or you can use cloud resources, as my colleagues did yesterday. But if you're a data scientist or want to, you can hire data scientists, they can just go and download the models and use them. And it depends on your budget, obviously. But let me remind you that bare metal, I mean, downloading and running the models offline is not free. Even free ones are not free because you need some resources, right? And it's not free. Here is the example of GPT-4 pricing. It says 3 cents for 1K tokens for the input. They are charging if you are using the 8K model. I don't know why this is not. Okay, we can skip this. Okay, but what's in the token, right? It's like they are defining it like 1.75 words because language models are not thinking like humans, right? They are chunking the words into smaller pieces, smaller, meaningful pieces. Like unhappiness is 3 tokens, not a word. It depends on your use case. Are you looking for a translator? Do you want to use it like a help desk assistant? I mean, remember the chart because they are specialized on some certain aspects. And there is the availability issue. Some models are not open for productization. You cannot earn money by using these models. And some models are for scientific use only. And you should check the license type. And of course, there are open source models and closed source models. If you are an intelligence agency, you may not want to use the closed source one. Okay. I mean, it's like the question, which car is the best? Is it Ferrari 911? Or if you want to go to picnic with your family, maybe not. So you should choose wisely. When I talk about large language models, actually, I forgot to mention something. They are trying to predict the next talk. So actually, they are like they are designed for completing the sentence. Right? You begin a sentence, and they tend to complete the sentence. They are transforming it to conversational models. But the idea is to complete or predict the next token in the sentence, like the neural network. And this shows the improvement of humanity on prediction. We started like Titanic, who died or who didn't die by just looking at the ticket. It's a famous exercise on Kaggle, like the classification problem. You try to guess or predict who is going to die or not. We came so long, we can predict the next word. So I'm not sure if you have seen this show. I don't want to give you some spoils, but it shows the place where the prediction can go. I mean, with enough parameters, we are talking about billions, maybe GPT-4 is not officially declared, but they are talking about 1 trillion parameters. But with enough parameters, maybe we can predict past or future or anything. That's all. Any questions?
Thank you, Fatih. You heard him. Questions? Fatih, yes, please.
Thank you. First, thank you for this really deep, like diving into the theme because like the chats, I mean, fight with the model that I couldn't imagine existed. So my question is, so how kind of do you see it's moving right now? Because there are a lot of models, different applications. Probably like in 2 years, it's going to be 100 models instead of current 10s and so on. But do you see like there's going to be like chat 5 that will kind of consume everything? How kind of your perception, how it will be? Or there are chances for smaller companies without 3 billion a year spending to actually build something like that?
Yeah, excellent question. That's the only part that is missing in this presentation, actually. I mean, there are some great problems that the language model companies are facing, like biased models, because the more data they load, the better the model become. But it also brings the bias problem because data is biased. And there is also toxication problem. They can generate, I mean, there was that question in Burak's presentation. You are trying to do something for kids, but you are scared of that can generate something that you don't want to. And it's really costly, and it takes very long times to train bigger models. So it requires lots of resources, human resources, and money, of course. That's why they don't survive very long. I believe if you can monetize or productize, I mean, like ChatGPT does, Google is trying to do it, but its API is not fully available right now. You have to wait. There is a waiting list. So it should. I mean, so I believe OpenAI is doing good because it will monetize it, and if it can use the money to invest more, I mean, it can win. But there are other ones, and if they can solve the training problem, because OpenAI has, like, when you ask it a question, it says, I know only at the end of September 21. I don't know the sooner events, and that's very annoying, honestly. I mean, they have to solve that training problem. If it is solved, then smaller models can survive longer, I believe.
Thank you, Vadim, for a question. I think Carlos had one.
In terms of the models, the three that you showed three types of models that have been the ones that are most popular. But have you checked the RWKV type of models, which combines RNNs with transformers? So
No.
they have some kind of attention, but not as robust, but they are faster at inference and faster at training.
No, unfortunately. Honestly, I don't have hands-on experience, but I'm going to check. But I know that RNN models, recursive neural network models, transformer models had killed them, like,
Yes.
but they survive, and I think, yeah.
Yeah, and these type of models are basically a combination of both. So you can get the benefits of both. They don't have as much attention, but it's something interesting that we will see problems for models or that direction. Maybe they can get to some state that is useful for some applications.
And the good thing here is, I mean, we didn't do much. We didn't invent a new thing. We are using just that we know. I mean, like, we didn't invent a new science or something. It's just statistics and mathematics and human power. So I'm sure that we can solve these problems.
Thank you. Any more questions? No? If not, then one round of applause for Fatih. It's great. Good.